Have you ever typed a simple request into an AI? Something like, hey, create a database for me in AWS. And then you hit enter and boom, it just works. It honestly feels like magic. But here's the thing, it's not magic. Behind that one simple command is this incredible, intricate dance that turns your words into real-world action. So let's pull back the curtain and see how this amazing process actually works. So yeah, how does it really work? How does your intention, just a simple sentence, become a fully configured running database? That is the core question we're going to unpack in this explainer. We're going to reveal the hidden architecture that makes it all possible. Now, right off the bat, we've got to challenge our biggest assumption. Most of us, we tend to think that the AI is this all-powerful thing doing all the work. But that's just not true. It's wrong. The AI, the language model itself, cannot touch your files. It can't run commands. It literally can't do anything on its own. Nothing. So if the AI isn't doing the actual work, what is? Well, to understand that, we need to look beyond the brain. We need to see the hidden architecture that actually gets things done. So let's do that. Let's pull back the curtain. You see, the secret isn't one single component, but three. It's a system, a collaboration, and understanding the distinct roles that these three players have is the absolute key to understanding how AI agents really function.
So let's meet the players. We're going to break down the fundamental components that make up what we call an agentic system.
First, there's you, the user. Your role here is absolutely critical. You are the one who provides the intent. You're setting the goal, you're asking the question, you're defining the task that needs to be done. Next up is the large language model, or the LLM. This is the part that we usually just call the AI. And the best way to think of it is as the brain. Its job is reasoning, planning, and making decisions. It figures out what needs to happen, but, and this is the important part, it doesn't actually do it. And this brings us to the crucial third player in this whole setup, the agent. The agent is the orchestrator, the go-between. It sits right between you and the LLM, and its job is to manage the entire process. It doesn't think or decide. Its job is all about coordination and execution. So let's just recap. We have a user with a goal, we have a brain to make a plan, and we have an orchestrator to manage things. But something's missing, right? A brain and a coordinator can think and plan all day long, but they can't actually do anything. They need, well, they need hands. And this is where tools come into play. Tools are the hands of the system. They are simply functions the agent can execute on behalf of the LLM. And these can be anything, from reading and writing files, to running terminal commands, searching the web, or even calling out to external APIs. The LLM decides which tool to use, and then the agent is the one that actually runs it. And this whole thing is powered by a brilliant little engine called the agentic loop. It's a simple, constant cycle of reason and act. Here's how it goes. The agent sends all the information, the goal, the tools it has, the conversation history, over to the LLM. The LLM thinks about it and requests a specific tool. The agent executes that tool, gets the result, adds that new information to the context, and sends it all right back to the LLM. And this loop just repeats, over and over, until the LLM decides the task is finished. This table really makes the transformation crystal clear. Just look at how adding tools builds a much more powerful system. Without tools, the LLM just gives you text responses. But with tools, the entire system gets an upgrade. The LLM can now request actions, and the agent becomes an active executor, managing that whole reason and act loop. Okay, so that's the theory. But what does this look like in a real-world application? Let's take a look at one of the most powerful use cases right now, a smarter way to search called agentic RAG. So first, a real quick definition. RAG stands for Retrieval Augmented Generation. It's a common technique where, before an LLM answers a question, it retrieves relevant info from an external knowledge base. This just helps it give you more accurate, more up-to-date answers. Agentic RAG takes this concept to a whole other level. You see, a traditional RAG system is reactive. It follows a fixed path to a single data source. But an agentic system, it's proactive and adaptive. It can use multiple tools to query multiple sources, dynamically choosing the best strategy for your specific question. It doesn't just follow instructions, it actually plans and solves problems. There's this quote from IBM that just sums it up perfectly. A traditional RAG is like a by-the-book employee who does exactly what they're told. An agentic RAG system is like a proactive and creative team that figures out the best way to solve a problem, taking initiative all on its own. So, if a single agent is like that proactive team member, What happens when you have a whole bunch of them working together? Well, this brings us to the next frontier, the multi-agent system. Let's just build on that last analogy. If a single agent is that creative team member, then a multi-agent system is like an entire organization. It's a collection of specialized agents, each with its own role and its own capabilities, all collaborating to tackle tasks that are way too complex for any one agent to handle alone. And the differences here are profound. A single agent, it works towards one global objective. But a multi-agent system is decentralized. Each agent can have its own local objectives. Learning happens in parallel, not one by one. The result is this emergent, collaborative system that can solve problems in a fundamentally different way. So, how do these AI organizations even structure themselves? Well, there are two main models. You can have a hierarchical structure with a leader agent planning and directing follower agents, or you can have what's called an equal-level structure, where all the agents act as peers, negotiating and collaborating to achieve a common goal without any central boss. Okay, let's pull all these pieces together and take a look at the big picture. We've gone from a single thought to a complex collaborative action. This quote just perfectly encapsulates the entire system. It really is a three-part harmony. The LLM is the brain, providing the reasoning. You are the director, providing the intent. And the agent. The agent is the executor that connects the two and makes it all happen in the real world. So the crucial point, the main thing to take away, is this. We are witnessing the evolution of AI. It is moving beyond being a passive thinker that just answers questions to becoming an active doer that can accomplish complex, multi-step tasks in both the digital and physical worlds. And all this leaves us with a fascinating final question to think about. We started with single agents. Now we've got teams and organizations of agents. As these systems grow into complex AI societies, what kind of problems are they going to solve that we can't even imagine today?